Welcome to Ray Diagramming 101. Today, you will learn about what is ray diagramming and how is it used. Ray diagrams are a representation of the possible paths light can take to get from one place to another. Oftentimes, it is seen from a source or object to an observer or screen. It is used to describe the images formed by either mirrors or lenses. But in today's video, you will know the basics of ray diagramming when dealing with convex and concave lenses. This is an example of a ray diagram, but we need to get in detail first before you can better understand this illustration, starting from here. This is what we call as principal axis, or axis, the horizontal line from which you will start drawing your diagram. Next will be the lens, which is the vertical line drawn perpendicular to the principal axis. The point where the lens and axis meet is what we call as the optic center. Of course, we have the object. The object is commonly placed on the left side to easily construct the diagram. In connection, most diagrams use an arrow as an object representation for convenience. As we go through, you will also observe points known as the focal points. Principal focus or focal points are the specific points where light rays either converge or diverge. We also have here the center of curvature or 2F, which is needed in placing the object. The distance between the lens and point F is called as focal length. Note that the focal length on both sides of the lens are equal in measurement. Now, we will proceed to the main light rays that determine the images. First, we have what we call as the central ray, that crosses the optic center of the lens and is not bent or refracted. The second one is called as the parallel ray, described by its parallel position with the central axis going to the lens. Take note that the parallel ray must bend going to the lens focal point on the right side. Lastly is the focal ray, which when observed is like the opposite of the parallel ray. It is bent going to the lens focal length on the left side and becomes parallel with the central axis after interacting with the lens. But as the lens change, the direction from which the parallel ray and focal ray go may change. And the last part of the diagram will be the image. The head of the image can be determined as to where the light rays intersected. In connection, light rays originated on the head of the object going through the lens. If the light rays didn't intersect, then no image will be formed. Constructing a ray diagram is not complete if you will not be able to describe the image formed, and this will be the concluding part of this video. The image formed when light rays strike the lenses are described in three characteristics, and these are the image type, orientation, and size or magnification. An image is said to be real when it is formed due to the intersection of solid lines in the diagram, known as real ray. However, it is virtual if a dashed line called as virtual ray intersected to form the image. Image orientation is simply how the image is placed in comparison to the object. The image is inverted if its head is pointing the opposite direction compared to the object. On the other hand, it is upright if it is standing in the axis like the object. The last will be the image magnification, or simply, how is the image size compared to the object? The image is said to be magnified if it is bigger than the object, and reduced if it is smaller. And that's a wrap. I hope you enjoy learning about ray diagramming involving lenses. Have a good day!